We're going to take a look at homework chapter 6.4 on radians, arc length, and angular speed. The first half of these questions is about converting from radian measure to degrees and degrees to radian measure. So we'll start with number 1. It says convert the angle in degrees to radians. Express your answer as a multiple of pi. So to convert from degrees we need to multiply by pi over 180 radians. So the degrees will basically cancel and you're left with radians. All right, so to go from degrees to radians, we're going to multiply the degrees by pi over 180. And if we're going to convert from radians to degrees, we're going to multiply by 180 over pi. So for number 1, 120 degrees, we multiply by pi over 180. The degrees cancel, and we're left with pi in our answer, but we'll have to reduce that fraction. So we have 120 divided by 180. Press math, enter, enter, and we have 2/3 pi radians. And they do want pi in the answer. We'll jump over to number 3. It says convert the following degree measure to radian measure. So we have negative 213.8 degrees. We're going to multiply by pi over 180. So negative 213.8 divided by 180, math, enter, enter, is equal to negative 1069 over 900 times pi. In question number 5, we're converting 14.4 degrees to radians, so 14.4. And we're going to multiply by pi over 180. So 14.4 divided by 180. Math, enter, enter, gives us 2 over 25 pi. It says type an exact answer in terms of pi. So we'll have to have that. We'll have to keep that in our answer. So 2 over 25 pi. In question number 9, convert the 72.7 to radian, but round to the nearest hundredth. So a little different this time. They don't want pi in the answer. So 72.7 times pi divided by 180 is 1.27. radians. I'll go ahead and jump over to number 12. Convert the radian measure to degree measures. So we have 7 radians. Now we want degrees in the answer, so I'm going to put my degrees at the top, so 180 over pi. Incidentally, we know that pi radians is equal to 180 degrees, which is why we can use it as a fraction, because it's equivalent to 1. So we want the final answer rounded to the nearest hundredth. 7 times 180 divided by pi is equal to 401.07 degrees. Okay. In this one, it says convert the following radian measure to degree measure. So number 14, we have 5 pi over 3. Going to multiply by 180 over pi. The pi's cancel. So we have 5 times 180 divided by 3. Math, enter, enter, and we get 300 degrees. Number 16, it says certain positive angles are marked in the given figure. Find the corresponding radian measures. Okay. I will be handing you a formula packet that has all of the radian measures and the corresponding angles. So, but this is a very good exercise. It's to practice converting from radians to degrees and back to radians again. So we're going to start with the XY plane. We have, what I'd like to do is just work with you to divide this up into degrees, and then we'll do the same thing in radians. Okay, so degrees, we got 0, and a full rotation is 360 degrees. Okay. Half a rotation is 180. I'll just keep taking halves. This is 90 degrees. Add 90 to 180 and we get 270. And then we can have our special angles. Let's see. All right, so I'm going to divide this in half again. That's 45 degrees. In half on the second quadrant, that's 135 degrees. In half over here would be 200 and let's see, 45 plus 80 is 235 degrees. I'm just gonna check that work there. 180 plus 45 is 225. And then we have 270, and 270 plus 45 is 315. Then we can look at the 30 and the 60. So we add 30 to 90. So 90 plus 30 is 120. And 120 plus 30 is 150, and so forth. Okay. So you could just keep going around and around, adding increments of 30 to get the rest. Now let's go ahead and do the same thing, only divide the circle up in using radians. And then that will help you answer this question. Try another color. So starting here, we have 0 radians, or in a complete rotation is 2 pi radians. Remember, pi is equal to 180 degrees. Then we can split it in half. We have 1/2 pi and 3/2 pi. So we see that 1/2 pi is equal to 90 degrees, and pi is equal to 180 degrees. If we split this in half, half of pi over 2 is pi over 4. So there's 1 pi over 4, 2 pi over 4. Here's 3 pi over 4, 5 pi over 4, 6 pi over 4, which is 3 pi over 2, and then 7 pi over 4. And then we could break it up again using increments of pi over 6, which is equal to 30 degrees. So there's 1 pi over 6. Here is 2 pi over 6, which is pi over 3. And then we have 3 pi over 6. Then we have 4 pi over 6, which is 2 pi over 3. 4 pi over 6, and then 5 pi over 6. And then 6 pi over 6, 7 pi over 6. 8 pi over 6, which is 4 pi over 3. 8, 9, 10 pi over 6, which is 5 pi over 3. And then 11 pi over 6. Okay, so we can really now see what the values are. So we see that 0 is 0 degrees is the same thing as 0 radians. 30 degrees is equal to pi over 6 radians. 60, or let's see, the next one is 45 degrees. That's equal to pi over 4 radians. 60 degrees is equal to pi over 3 radians. And then 90 degrees is equal to pi over 2 radians. Let's see, what else? And it wants to know, let's see, what is 135? Now we could look at the diagram, or we could go back to just conversion. So 135 times pi over 180. All right, so you don't have to sketch it out on a circle if you don't want. And then we use our calculator to simplify. So 135 divided by 180, math, enter, enter, and we get 3/4 pi. Okay, and then we have, let's see, 180 degrees we know is pi. And then we have 225 degrees we know is that 5 pi over 4, but we can easily calculate that by just multiplying by pi over 180. So 225 times, or sorry, divided by 180. Math, enter, enter, and we have 5/4 pi. And then 315 degrees is equal to that 7 pi over 4. We can verify that. 315 divided by 180. Math, enter, enter, and we get 7 pi over 4. Okay, so that is question number 16. In question number 17, find a positive angle and a negative angle that are coterminal with the given angle. Okay. Let's see, if we're wanting to have an angle that's coterminal, we need to go an entire rotation, a whole rotation, okay, which is 360 degrees, or if we're in radians, 2 pi radians. So we only need to add 2 pi or subtract 2 pi. So with pi over 2, we're going to add 2 pi. And what we can do is, for now, just look at the fractions. We're going to add 1 plus, or 1 over 2 plus 2. Math, enter, enter, and we have 5/2 pi. So there is one angle that is coterminal with pi over 2. And then to get a negative angle, we subtract 2 pi. So that's pi times 1/2 minus 2. 1/2 minus 2 is negative 3/2 pi. So there's our two angles that are coterminal. One's positive, one is negative. Next one we'll look at is number 20. It says find the complementary and supplementary angles to 3 pi over 10. To find the complementary angle, we subtract it from 90 degrees, or if we want to convert that to radians, we take 90 times pi over 180, and we get pi over 2 radians. Okay, so we subtract pi over 2 minus 3 pi over 10, which is 1 minus 3/10 pi, which is 7/10 pi. To find the supplementary angle, that's 180 degrees if we're in degrees, or pi radians. So we have pi minus 3 pi over 10, which is pi times 1 minus 3/10. Oh, I just realized that was a 1/2 there. Sorry about that, because this is 7/10 pi. 1/2 minus 3/10. Need to change that answer. So 1 divided by 2 minus 3 divided by 10. Math, enter, enter. We get 1/5 pi. Okay. Okay, so the supplementary angle would be 1/5 pi. The complementary angle is 1/5 pi. The supplementary angle is 7/10 pi. Okay, that's number 20. I think I'll go down to 21 here. For number 21, we're looking at completing the table where you have the distance or arc length is 4 feet, radius is 5 1/3 feet, and we want to find the angle. So the angle is equal to S, which is the distance, divided by R, which is, so this is the distance divided by the radius. Okay. So theta is equal to 4 feet divided by 5 1/3 feet. The only way to do this is if the distance and radius are in the same unit of measure, which they are, so they can cancel. So we have 4 divided by, I'm going to put this in parentheses, 5 plus 1/3. And it's asking to express it as either an integer or a decimal rounded to the nearest hundredth. So we press enter, and we get 0.75. And we are in radians. Okay, and number 22, it's looking for the distance in yards. The radius is also in yards, that's good. So theta is the distance over radius. So the distance is r theta, which is 5.3 yards times 3 pi over 2 radians. So 5.3 times 3 pi divided by 2 is 24.98 yards. And that's what our distance is. In number 23, through how many radians does the minute hand of a clock rotate from 1250 to 1:30? Okay, let's draw a clock. There's our 12, 6, 3, 9, 1, 2, 4, 5, 7, 8, 10, 11. Okay. And we can see our quadrants there. So at 1250, the minute hand is on the 10. And then at 1:30, the minute hand is down here on the 6. And so the clock goes clockwise from the 10 to the 6. So the question is, how many radians did that rotate? Well, we can see that we have pi, but from 12 to 6, all right? So that's half a circle. So we know there's pi, but from the 10 to the 12, we can see that we can split that up into 1, 2, 3 segments. And if it's 9 degrees, each one is 30 degrees, or pi over 6 radians. Okay, so from 10 to 11 is pi over 6. From 11 to 12 is pi over 6. So 2 pi over 6 is pi over 3, which is 60 degrees. Okay, so that's 60 degrees, which is pi over 3, plus another pi is 1 1/3 or 4/3 pi. And that's how much it rotated, the minute hand rotated. Now, number 24, we're going to talk about linear speed and angular speed. So a flywheel with a diameter of 16 centimeters is rotating at a rate of 14 radians per second. What's the linear speed of a point on its rim in centimeters per minute? Okay, so the diameter is equal to 16 centimeters. It is rotating at a rate of 14 radians per second. So our angular speed is 14 radians per second. And it's asking what is the linear speed of a point on its rim in centimeters per minute. I see we have centimeters, but we have seconds here. So we're going to have to convert seconds to minutes. Okay, so the angular speed, I guess I could work this out in another color. So that's my given information. So, and we want to know what is the linear speed in centimeters per minute. Okay. So the linear speed formula is, that's usually v, velocity, is equal to the radius times the angular speed. Now we have diameter, but we need the radius. So the radius is half of that. So v is 8 centimeters. And then the angular speed is 14 radians per second, but we need to convert the seconds to minutes. And so we know that there are 60 seconds in 1 minute. This ratio is equal to 1, which allows us to multiply it by this fraction so that we can cancel the seconds, and now we have centimeters per minute. So V is equal to 8 times 14 times 60, and we get 6,720 centimeters per minute. So that's the linear speed. The next one is a little more involved. Let's see. So number 25, let's go ahead and set this one up. When Brett and Will ride the carousel, Brett always selects the horse on the outside row, whereas Will prefers the row closest to the center. These rows are 19 and a half or 19 feet 6 inches and 14 feet 7 inches from the center, respectfully. So here's the center. Here's one, we'll call it R1, and then we'll call this R2. Okay. So it's a carousel. We've got the center. We know R1 is equal to 19 feet 6 inches, and R2 is equal to 14 feet 7 inches from the center. The angular speed of the carousel is 2.2 revolutions per minute. Okay, so the angular speed is 2.2 revolutions per minute. So we need to know what distance is traveled in one revolution. So since one revolution is 2 pi radians, we multiply by 2 pi. And then we could get radians per minute. 2.2 times 2 pi is equal to 13.823. Okay, so the angular speed is 13.823 radians per minute. So what is the difference in miles per hour in the linear speeds of Brett and Will? Well, we're going to have to change the feet and inches to miles, because we know that, let's see, if we're looking at the difference of linear speeds, linear speed is the radius times the angular speed, okay? So our radius has to be in miles, and our angular speed has to be in radians per hour, okay? So we want this in miles per hour, okay? So this is what we want. Let's take the radius for, let's see, for Brett. So that's R1. And let's convert that to from feet to miles. Okay. So we have 19.5 feet. We're going to multiply by 1 mile over 5,280 feet, because there's 5,280 feet in a mile. So 19.5 divided by 5,280 is equal to 0.00369. And then for R2, we have 14 feet 7 inches. So 14 plus 7 divided by 12 is 14.58 feet. Multiply by 1 mile over 5280 feet to cancel out feet. Divide by 5280, and we have 0.00276 miles. Okay, so now we've expressed the radius in terms of miles. That's good. And now we're going to express the angular speed in terms of hours. So if we have minutes in the denominator, I've got to multiply by a fraction that gets rid of the minutes. So there's 60 minutes in 1 hour. So W is equal to 13.823 times 60, which is 829.38. And that's radians per hour. Okay, now we're going to, let's take a look at the problem again. What's the difference in miles per hour of the linear speeds? Okay, so let's get the linear speed is, I want to express it in terms of the difference of the two speeds. So let's say V1, which is Brett's linear speed, minus V2, which is Will's linear speed. And so V1 is going to be R1 theta. V2 is going to be R2 theta. I'm sorry, omega. And so we're going to multiply R1, which is 0.00369 miles, times omega, times omega, which is, what is that? 820. Oh, I think what we could do is factor out. Yeah, we can factor out the W so that we don't have to write it so many times. All right, so we're factoring out a W, and then we have R1 minus R2. Okay, so we've got 829.38 radians per hour times R1 minus R2. So R1 is 0.00369 minus 0.00276, and that's miles. Okay, so we've got our 829.38. We're going to multiply it. Times, there we go. So we're going to multiply by the difference of 0.00369 minus 0.00276. And we have 0.771, 0.771, and this is miles per hour. is our final answer. 0.77 miles per hour. And that is it for this homework. So you should be able to do 6.4. Have a good evening.